So this is the 9.5 warm-up review. It's a good review of what we've done so far with logarithms. We are going to be skipping the graphing problem at the bottom, number 4, since we just aren't going to be having time to get to the graphing. It says use properties of logarithms to evaluate without a calculator. So I see that these all have the same base, so I know it's all going to be log base 5. Because this is expanded, I'm going to condense it, and it'll be 4 times 50 divided by 8 because of that minus sign. Well, since I don't have a calculator, let's do some simplifying. This would be log base 5. This becomes 1, and that becomes 2, because 4/8 is 1/2, and then 50 divided by 2 is 25. And I then know that it's this is equal to x, so 5 to the x equals 25. So I know that the exponent must be 2. The answer to this must be 2. I like to write equals x when I have to solve a logarithm so that I can see that it's 5 to some power equals 25. All right, let's go to number 2. Log base 11 of 3 is approximately 0.46. So I have to use the fact that I know that, which means I'm going to need to rewrite each of these logs somehow using log base 11 of 3, because I know that I want to use this piece of information. I'm going to rewrite this as log base 11 of 3 to the 1/2 power, because square root means 1/2. And then I'm going to move that exponent to the front, and I get 1/2 log base 11 of 3. And look at that. I have managed to write this using log base 11 of 3. So I was able to use that. I have it right here. And so I know that it's 0.46 times 1/2. Oh, I meant to write 0.46, sorry. This is then 1/2 times 0.46. I can do that, and I don't need a calculator to do that. That'd be 0.23. That's my final answer. All right, let's do letter B. When I look at this, I'm thinking that 363 could be divided by 3. So I'm thinking I'd be able to rewrite this using multiplication somehow. And 363 divided by 3 goes in once, twice, once, so this could be rewritten as log base 11 of 3 times 121, because that's what 363 is. So then I could rewrite it as log base 11 of 3, which is what I wanted, plus log base 11 of 121. Well, I know what log base 11 of 3 is. It's 0.46. I also know what log base 11 of 121 is, because this is asking me 11 to what power is 121? It's 11 squared. So plus 2. So my final answer is 2.46. And I didn't need a calculator. All right, number 3. Expand the logarithmic expression, right, written here. So this time it's condensed, and I'm going to expand it. So I have log base 3 of 7 plus log base 3 of x squared minus log base 3 of y to the 6th. Because this is multiplication becomes addition, division becomes subtraction. The only other expanding I can do is I can move these exponents. So I get log base 3 of 7 plus 2 log base 3 of x minus 6 log base 3 of y. And that's my final answer. All right, and we get to skip this problem here. And then we're going to move on to this page 2 review. It says, again, to evaluate without a calculator, log of 1,000. I remember that this is a base 10 when they don't give me the base. and I always write equals x, so 10 to what power equals 1,000? I know it's 10 to the third. So this next one equals x, so 3 to the x equals 1/27. I really don't like that 27 being in the denominator, so if I bring it up to the numerator, I get 3 to the x equals 27 to the negative first. If you cross the line, it changes the sign of the exponent. All right, so then I'm going to write each of these using a base of 3. 3 to the x equals 3 cubed, because I know that 27 is 3 cubed, to the negative first. Power to a power, we multiply, so 3 to the negative third. They have the same base, so x equals negative 3. Right, natural log of e to the 1.73. Well, I know that natural log means log base e of e to the 1.73, because therefore I can say equals x. So e to the x equals e to the 1.73. They have the same base, so x is 1.73. Let's see, log base 6 of 2 plus log base 6 of 3. Addition means multiplication when they have the same base, so 2 times 3. This is going to be log base 6 of 6. Well, 6 to what power equals 6? Just to the first. Let's go to number 5. We've got the same base, and we have subtraction, so that's division. So log base 5 of 200 divided by 8. If I'm not sure what 200 divided by 8 is, I can kind of do that off to the side, see, or I could try reducing the fraction. Maybe that's easier. Some people, rather than doing the division, would just rather reduce the fraction if they don't have a calculator. They're both even, so that'd be 100 divided by 4. Well, now I know. 100 divided by 4 is 25. So I know that this is log base 5 of 25. So 5 to what power is 25? 5 to the second power. Right, number 6. None of these have a base, so it must be a base of 10. But we've got subtraction, which means division, and this 1/2 here is going to be an exponent. And so that's probably the first thing I would do, is I know that this is 400 to the 1/2, or the square root of 400. So I know that this is log of 85 minus log of 17 plus log of 20, because the square root of 400 is 20. Now I can do, since they all have the same base, which is 10, I can do division here and multiplication. So I've got log. I've got log of 85 divided by 17. I'm going to do that first, and then multiply by 20. 85 divided by 17, I'm thinking is 5. Let's see, what's 17 times 5? 7 times 5 is 35. So yes, so this becomes log of 5 times 20, which is log of 100. Well, I know what the log of 100 is, because this base here is actually a 10. 10 to what power is 100? 10 to the second power. This next one says rewrite without logarithms, so we're going to be solving for x. So I've got, that says 1/3. I'm pretty sure that's a 1/3. Yes, 1/3. So I'm going to first put that right here, and I have natural log of x equals natural log of a to the 1/3. So the natural log of x equals the natural log of the cube root of a. Well, since these both say natural log, I know that x must be the cube root of a. Let's do number 8. Log of x equals log, oh, this 4, first of all, is going to get moved to here. Log of a minus log of b to the 4th. And I know that subtraction means division. So log of x equals log of a divided by b to the 4th. Again, since they both say log, we know that x must equal a divided by b to the 4th. So we solved for x.